Yeah, my talk is about SysML v2, the next generation of the systems modeling language. So let's start with it. And well, imagine we were still developing software with punch cards today. This is what it would look like in front of software development departments. And that's nonsense, of course. No? If we hadn't developed software development technologies further, we wouldn't have the systems we know today. But it shows that it's important, well, to sharpen our source. No? This is the only way we can develop ever more powerful systems. And people also play a role, of course, and project heroes can develop even better systems despite the tool limitations. That's why here the curve of our engineering tools capability is below the curve of the systems we develop. But if a company does not further develop its tools, the gap of the laziness, that's how it's called here on the slide, will increasingly become a problem. And a tool here, by the way, stands for software applications, but also for methods and other things. So it's not only the software application part. So, and the systems modeling language, SysML for short, is such a tool. It's a general purpose modeling language for modeling systems. And you can create and visualize models with SysML. And it mainly represents requirements, the structure, and the behavior of a system. And we are on the system level, so not on a software, mechanical, electrical, we're on the more abstract system level. And it's just a language, nothing more. So it's not a methodology, and it's intended to be independent of all the methods and practices out there. So in a development project, there are a large number of digital artifacts that are networked with each other in various of ways. So here's an example. A very small example, but it already shows the challenge. For example, we have requirement specifications. So finally a document, but probably in a tool managing all the requirements in a database. And of course, we have many of them. There's not only one requirement specification, there are many of them. And they are linked to a source code which satisfies the requirements. We must manage this link. And they are also linked to CAD models. So this is a project for a system, including the mechanical components, electrical components, and so forth. And maybe the CAD models or one of the CAD models also linked to the software because we use parameters of the mechanical dimensions somewhere in the software. We do safety analysis, which is linked to requirements and maybe only to the CAD models. We have simulation and analysis models also linked to all the other repositories. And we have here a lifecycle assessment tool for the sustainability analysis. And of course, we also have many text documents and spreadsheets in the project. And it's a nightmare to keep track of everything here. And of course, error happens, especially when something is changed and not everything is updated consistently. And the information about the overall architecture and the overall requirements of my system here is implicitly hidden in this network. But it's not inside the source code, it's not inside the CAD models or any of the other artifacts here. And that's where SysML models come into the game. They describe the overall system, the requirements and the architecture. That means the problem space and the solution space. So it's therefore naturally the glue logic between all the other engineering artifacts. And this picture here should not be misunderstood. SysML is not intended to be a central repository. So all the other tools, of course, they still have their own data and they can be still continue to collaborate directly with each other. But naturally, a SysML model plays a very central role, the glue logic, or the table of content of the systems engineering project. It's the backbone of the digital thread. So coming back to SysML v2, who develops SysML? Well, people, users, academics, tool vendors, and so forth. And let's jump back to the year 2017. That was not the day of the birth of SysML v2 or v1, but we took one of the first group pictures of the team that developed the next generation SysML v2. And the working group behind SysML v2 meets 4 times a year for real, and otherwise we have several web conferences that take place, well, every week, the whole year. And this photo was taken at a meeting in Brussels in 2017. Over the time, the interest grew, and so that the group, this is 2019, just before COVID. And well, this was then during COVID, or the first time we were allowed to meet again. And this picture here is from September this year in Chicago. So we still work on SysML v2. It's not final yet, but will be very soon. I show you that in a few minutes. So overall, the team behind SysML v2, it's called the SST team, the SysML submission team, had more than 200 members, so more than 200 people from over 80 organizations from all over the world. So that sounds really a lot, and it was, or still is, a huge effort to create the language. Now, this team is not based on a legal entity or so. It's just a group of enthusiasts who are interested in developing the SysML v2. So let's have a more detailed look on the long and winding road to the language. How is it developed? And then, of course, I will also show you some examples of SysML v2. So first of all, it should not go unmentioned who is responsible for SysML. It's the OMG, called Object Management Group. And SysML is also defined as an ISO standard, at least SysML version 1. SysML v2 is still work in progress. And the OMG celebrates its 35th birthday this year. And OMG is responsible for many specifications. So they have more than 200 specifications in their catalog. Maybe you're familiar with UML, the Unified Modeling Language is from the OMG, but they also have domain-specific standards like Health Level 7 for medical devices and radar technologies and so forth. So the SysML version 1.0 was published in 2007. And the latest and last version of SysML 1.7 was published in 2022. And already in 2009, so 2 years after the publication of SysML version 1, the OMG published a so-called request for information, which is a questionnaire to the industry to ask the people, how do you like SysML v1? What is missing? What's wrong? What's bad? And so forth. And the result of this request for information that was that nothing was done for the time being, but it was then not until 2014 that working groups were set up to prepare the step to the SysML version 2. And the next official step for the SysML version 2 is the so-called RFP, the request for proposals. It's a list of requirements for the language. And this request for proposal is published by the OMG. And that was December 2017. And at the same time, at the same meeting, the previously mentioned SST team was chartered to develop the SysML v2, so to provide the answer to the RFP. And the team worked 6 years and submitted in the first quarter of 2023 the SysML v2 specification to the OMG, which adopted it, which does not mean that it's already published. It's adopted, so accepted, but at the same time, the OMG chartered so-called finalization task forces, which finalize the submission. And well, an FTF can run for 2 years, and well, they will run for 2 years. So it's planned to finally submit SysML v2 in March 2025. And then SysML v2 is officially published. But in the meantime, tool vendors already work on tools, and some already have published their tools. For example, IBM already published their product. So they have not to wait for the official publication of SysML v2. So projects can already start working with SysML v2 if they like. So why do all these people work on a new version of SysML v2? SysML v1 is there and has not even fully arrived in many companies yet. But there's not just one main reason, but a multitude of reasons why we did that. So the workplace of a systems engineer shifts more and more from this analog world to the digital tools. And the analog world, well, it's not precise, but the systems engineering world is very document-based. This has this analog touch. Now, if you store all your information in Word documents and in Excel sheets, it's a kind of analog touch. What we mean here by digital tools is that we have tools that can access the engineering data and work the data and support the engineers. And we have many old problems, a lot of new challenges now in the engineering domain. An overall name is now digital engineering, pushed by the Department of Defense. There's a high demand for managing this digital thread, to create digital twins, to create simulations on the system level, automatic analysis. We need more precision. We need model interoperability. We must be able to manage all the complexity. MBPE stands for model-based product line engineering. So we would not like to manage a single system. We would like to manage a whole product line with all the variants and so forth. And SysML v1, the previous language, is based on UML. And UML is a 30 years old modeling language created for object-oriented software development in the 1990s. So you can imagine that this can hardly be the foundation for the systems engineering modeling language for the next 15, 20 years that can face all these challenges. So that's the reason why we developed SysML v2. So let's have a look on the cover features of SysML v2 and their potential impact on engineering. Of course, I have not the time to show you all of the features. The whole specification documents have more than 2,000 pages, so that's a lot of stuff in there. It's a very capable language. But let's start with this one. One of the most prominent features here of UML and SysML v1 are the diagrams. So if you already know those languages, then you very likely know the diagrams, or mainly know the diagrams. So it's the user interface of the language. And SysML v1 has one phase, the diagrams, and SysML v2 has two phases. And that's new, and that's very interesting stuff. Let's start with the first phase, the graphical notation. So on the first view, it looks quite similar to SysML v1. You see in the upper right corner, you see a SysML v1 diagram showing a very simple structure of a drone. A drone has a battery and has 4 engines and so forth. And the larger diagram on the left side is the SysML v2 notation. So we have boxes and lines. And there are some details some differences in details between v1 and v2, but it's basically the same. But quite new is this one. SysML v2 introduces a textual notation. So it's a little bit like a programming language. I'm not sure if you can call it programming language. It's called a notation. We have a textual notation. It's equivalent to the graphical notation. So both are notations representing the model. The model is a repository where we store all the model data. And this textual notation will have a big impact on the systems engineering community. So I think one of the most important impacts is it is a door opener for software engineers. Software developers usually don't like modeling, at least UML's modeling and so. But they love their development environments in which everything is more or less text-based. And since there's hardly any complex system without software, it's important that software engineering works closely with systems engineering. But we can observe in practice that there's a huge gap in many organizations between the systems engineering who work with SysML v1, so all the boxes and lines diagrams, and the software engineers with their integrated development environments. And now with SysML v2 textual notation, they come much, much closer. And we can already observe that I saw a presentation a few weeks ago in a conference from Bosch, and they said, wow, now the software engineers come to us systems engineers and they would like to work with us together with SysMLv2. So most SysMLv2 examples show system structures, like my very simple example before with the drone structure. Therefore, I show you now here a brief overview of examples of the behavioral modeling. So we can model structures, system decomposition, and how all the parts are related with all the interfaces. But we can also model the behavior of the system. And there are three main pillars in the behavioral modeling. And one is the modeling of actions. So actions specify the execution order of tasks performed by the system. You see on the right side the graphical notation. This is quite intuitive and similar to other languages which can specify processes. And if you already know UML or SysMLv1, it looks quite the same as the so-called activity diagrams. And on the left side is the textual notation of the same model. It looks like a programming languages. So we have the statements for the order, first start, then do this, then that, and so forth. And we have an if statement and so forth. Of course, it does not show everything. You can do much more. There are loops and forks and synchronization nodes and so forth. Another one is the states. Now you can specify state machines. Again, a very simple example here. It's nothing special. It's just a state machine. Of course, there are more elements available than shown here on this slide. And we can specify the communication between system parts called messages, that we send a message from one part to another. Message not only in the sense of software data, we can also send a physical thing to another one, which is also called message in SysML. So in SysML v1 or UML, this is called the sequence diagram, if you're familiar with that one. And SysML is a general purpose language, so it has very high-level concepts built in the language. And you can extend it by defining concepts in libraries. And then with that, you can include your own domain-specific concepts into the language. Like we can do this in software. No? In software, I can load a library, and then I have new capabilities, new functions, new elements that I can use, and you can do the same here in SysMLv2. So here's an example. You see a special keyword here, PLE feature. So this is an example of a product line. So we defined product line concepts like features and feature configurations in a library, and then we can use it in our models as a little bit like as new model elements. So this PLE feature gets a new keyword that we can use, and you can see it in the textual notation here on the right side or in the graphical notation on the left side. And it's a library-based language extension approach, which is very powerful. And SysMLv2 also already contains some domain libraries. For example, all the ISO 80,000 units and quantity kinds, they are a mandatory part of the language. So if you use SysMLv2 in a modeling tool, you already have all the units and quantity kinds available. And there are other libraries that comes with the language, but you can define your own libraries to extend it. Yeah, a sparkling game-changing feature is the SysMLv2 API and services, which enables the model interoperability and much more. You remember this slide? So in practice, the challenge is here that all the different tools have to connect to the SysML modeling tool. And these are different tool vendors. Now you have to connect your requirements tool from I don't know, from Siemens with a modeling tool from IBM or so. And you probably all know this challenge of exchanging data from tool to tool without standards. It's almost impossible. And it's a nightmare in projects. And this is where the SysMLv2 API comes into play. We have a standard here. A standard how to access a SysML model, reading and writing the model independent of the implementing tool. So it's completely independent. So if the tool says we are conform to the standard, a third-party tool can access the data without knowing the concrete implementation of the tool. So IBM, Dassault, and so forth, all these tools can be accessed. So that's extremely powerful. It's a missing link in system engineering. It's a pain in many projects at the moment. Of course, you can also see the other way around. You can also use the API as a facade, and you can pretend you are a SysMLv2 tool by exposing your data outside to the via the SysMLv2 API. This will certainly only be a subset of SysMLv2, but as an example, an Excel with a part list of a system can expose this data to the outside through the API as SysMLv2 part elements. So also a very powerful mechanism. Yeah, if one more headline from the cover page of the SysMLv2 features is a big thing is that SysMLv2 is not based on UML anymore. In particular, the tool vendors, they're here on the front line, were not so happy about this decision because they cannot use their UML-based modeling tools anymore. So it's a big business case for them and a big investment to create new SysMLv2 modeling tools. But most of the other ones in the community are happy about it. UML is not bad, but it does not satisfy the systems engineering needs that we have today. So it's completely independent of UML. And what we did, we developed a new foundation. It's called the kernel modeling language kernel. It has a precise semantics. It's based on mathematics. And SysMLv2 is based on kernel. It can also be used to create other modeling languages than SysMLv2. So kernel is independent of SysML, and it's already under discussion to develop a UML version 3 based on kernel. So introducing SysMLv2 in an organization will be definitely a big impact for the organization, even if the change is welcomed. Organizations are complex, and every change leads to resistance and behavior that is difficult to plan. And if you're already tearing up the road in your organization to lay the SysMLv2 line, then you should also lay another line before you close the road again, because the next change, the next big change is just around the corner. And I would recommend thinking about both together. The text notation of SysMLv2 is not only a door opener for software engineers, it's also a door opener for large language models. A large language model can easily generate Python, Java, C++ code, so it can also generate SysMLv2 text notation code or read and understand it. And it already happens, and we can see it in projects and in the community. And I wrote a book together with Doug Rosenberg and Brian Moberly about AI-assisted NBSE with SysML. Doug contacted me, I think, 2 years ago and said, well, that's a big thing. Let's write a book about it. So it's mainly Doug's book, and I supported the SysML part in the book. And the book describes how to use AI assistants to effectively develop systems so you get quick results, fast feedbacks, and so on. Yeah, quickly some examples. So we defined here an AI persona called Forrest Einstein, who's an expert for forest fire observation systems. And now we can ask this persona for some use cases, and he provides me a list of use cases with brief descriptions for such a system. So early detection, real-time monitoring, and so forth. You can also work with images. I think it's a pretty cool feature. Instead of just text, videos are also possible. And in this way, use cases, for example, can be visualized directly in a workshop, in the workshop setting, which greatly promotes the creative process and accelerates the development. I already tried this in real projects. Now we defined use cases and said to the AI, create a storyboard for the use case, and we get pictures. Some of the pictures are very funny because of all this hallucination stuff, but which also increased the mood in the workshop and also the creativity. And we find lots of new cool features for the system. Now we can use ChatGPT or any other large language model to generate SysMLv2 text annotation. So here we gave this AI the use cases from before, and it generates the text notation for SysMLv2. So that makes the life of an engineer much easier. If you already know what you would like to model, you do not have to click through the modeling tools or write the text notation. You can just create it. And then, of course, you have to verify if it's correct. Another interesting feature if you work with AIs as an assistant is you can change the roles. Here we changed the persona from an expert of forest fire detection system to a production engineer. And again, we ask for use cases, and now we get use cases from the production perspective about scaling and all this stuff. And you can also ask, give me some arguments from competitors and of anti-use cases, misuse cases, and ask from the perspective of thieves or and so forth. Well, that's really nice to change the perspectives here. And the use cases you saw before were quite simple, just a little bit of text. And you can define a template of your engineering methodology like here. So we define here a use case template. It's a use case name is verb plus noun, and then list the actor, then the objective, and the trigger result, and then provide a basic flow. It's very simple to provide a template, and then we get use cases in this style. So according to our template, with the name and so forth. It's almost perfect. So it's really impressive what already is possible there. And that's like coming back to SysMLv2. Imagine now you have a modeling tool that you simply tell what you want to do. It's already available that you can talk to AIs in natural language without any problems. And the tool creates the model for you and gives you tips on what could be improved and where are conflicts with existing artifacts and so forth. And if you don't understand the model, you get an explanation and so on. So that would be really great. And it was a dream a few years ago. And now it's almost within reach. No? So it's almost there. So it's really, really cool. And we will see those tools, I guess, in the near future. It's already there. I know a small company in the US, they were supported by the US Army. They have a high interest in SysML modeling too. And they already created a first prototype. Yeah, speaking of tools, and that's the final topic here of my talk. Let's have a look at the tool SysMLv2 tool landscape, what's already there. Well, I mentioned it before, there are already SysMLv2 modeling tools available for real projects. Some of them are only announced and not published yet, but you can already start working with SysMLv2. And there's two interesting companies here, or tools. One is SysOn. It's an open source tool developed by people who developed Papyrus in collaboration with Ubeo, if you're familiar with this tools. And another tool is Seaside from the company SenseMetry. It's a Visual Studio Code plugin. It focuses on the text notation. It's also open source. And in the past, we did not have an open source scene in SysML modeling or in NBSE at all. And you know, it's from the software engineering domain that open source, it's a very powerful enabler for progress and for complete new features. And now we also have here the possibility that open source will push NBSE forward. So it would be really great if this happens. Finally, a few impressions of the SysMLv2 tools. So this is SysOn, it's web-based. So you don't have a client on your laptop. You just call an URL and then you can do the modeling. It's web-based. You see here a view. On the left side, you see a tree of your model. And well, this is Seaside integrated in Visual Studio Code with the typical Visual Studio Code features, refactoring stuff and so on. That's available. And I know that SysOn plans also provide text notation, and Seaside also plans to provide graphical notation. So then we have both tools, also both worlds, whatever you like. Yeah, and with that, I'm come to the end. So maybe there's some time for any questions, or I saw the program a bit later after the next keynote and talks. And otherwise, if you have any questions later, you can just contact me here. You see my email address, or you will find me on LinkedIn and other platforms. So thank you very much.